So you probably already know how to do the critical value, but I'll help you calculate it. The critical value is that chi-inverse formula in Excel 2012. So you're going to do the, I'll just kind of put it up here in G12. You do the equal sign and just start typing chi, and it's the chi-square inverse to the right tail one. And the probability is the number that they gave you, which was the 0.05. Now the degrees of freedom is rows minus rows minus 1, number of rows minus 1 times number of columns minus 1. And don't count the totals here. So there's 1, 2, 3, 4 rows minus 1 is 3. 2 columns minus 1 is 1. So we have 3 times 1 or 3 degrees of freedom. So 7.815 is our critical number. And what that means, it's kind of like your z-score. And if you get a chi-squared number that is greater than this, then you're going to get to reject your null hypothesis. But in this case, this is going to mean that you have probably a pretty big p-value. But let's continue to see what our p-value is. The way you compute your p-value is you come in here, I'll just do it right here in this cell G13. I'm going to do an equal sign to start typing chi, and it's chi-squared distribution to the right. The x value here is your actual chi-squared number, so you the 5.315, and then your degrees of freedom you just calculate it to be 3. And so that's 0.150, so that's a large p-value. And we all know what to do with a large p-value, right? We fail to reject. I didn't care. I only did 4 decimals. I didn't do this, whatever. So we fail to reject the null hypothesis. There is not sufficient evidence to support the claim that the professor's grade distributions are not equal. Yay! Isn't this fun? Okay.